Good morning students, I hope you all are good. Today we are going to discuss a new lesson. Lesson 3, Magnetism and Magnetic Effects of Electric Current. What is our lesson? Magnetism and Magnetic Effect of Electric Current. In that lesson, today we are going to discuss a new topic, magnetic field produced along the axis of the current carrying circular loop. It is very important 5-mark question. In our previous class, we have discussed magnetic field produced along a straight conductor carrying current. Today we are going to discuss magnetic field produced along the axis of the current carrying circular coil. In our previous class, we have discussed and derived straight conductor. Today we are going to discuss and derive what is that circular coil. What is that circular coil? So consider a current carrying circular loop. What is that? Current carrying circular loop of radius is R. See that? One circular loop. Consider a current carrying circular loop of radius. What is that radius means? Radius is considered to be R. The center of the circular loop, we have given the name. So consider a circular loop of what circular loop? Current carrying circular loop. That current is represented by I. See that? This is the current carrying circular loop. Then current flow direction I mentioned in the diagram. The flow of current which direction, clockwise or anti-clockwise, I mentioned that arrow mark in the circular loop. So we have to write the sentence. So what is this? Circular loop of radius. What is that radius? Radius is R. What is here? R denotes radius of the current carrying circular loop. What is I? Current in the circular loop. We have to find what we are. Good morning students, I hope you all are good. Today we are going to discuss lesson 3, magnetism and magnetic effect of electric current. What is that? Magnetism and magnetic effects of electric current. In this lesson we are discussed so many topics, isn't it? Today we are going to discuss a new topic. What is that new topic? Magnetic field produced along the axis of the current carrying circular coil. What is that? Magnetic field produced along the axis of the current carrying circular coil. This is very important 5-mark question and also problem based question. In our previous class, what we discussed is same. See that the magnetic field produced along the axis of the current carrying, not circular coil, straight conductor. We derived the final equation and mathematical steps all. Am I correct? Today we are going to discuss the magnetic field produced along the axis of the current carrying what? Circular coil. So what is the magnetic field in the circular coil? So consider a circular coil. What circular coil means? Current carrying circular coil. So see that? Consider, first point, consider a current carrying circular coil of radius, that radius denoted by R, capital R, carrying circular coil. See that? I will draw the diagram. Circular coil. Circular coil of radius is R, that represents the radius. What is that? R. What here? R denotes radius of the circular coil. Then current carrying. So here, what is I means? Current in the circular coil. So current flows in the circular coil. I mentioned the diagram. Arrow mark in the circular coil. This is the direction of the, what is that? Coil. Current in the circular coil. Now what we have to find means we have to find the magnetic field in the circular coil. we can't able to find the magnetic field directly in the circular coil. So what circle do means we have to assume a point P. So P is the point. Current. What is I denotes current in the circular coil. So our aim is to find out the magnetic field in the circular coil, isn't it? So I have to assume the point P. The distance between point P and the center of the coil is represented by center of the coil is O, Ez. What is that? Ez. The distance between P to center of the coil is represented by what symbol? Ez. Next, why I want to assume the point P means because we can't directly find the magnetic field around the circular coil. So that's why I use that or assume that point P. First I want to find the magnetic field at the point P. Then to find out the whole magnetic field around the circular coil. The coil carrying the current. So point P to O. The distance between point P to O is what is that? Ez. Next, here the point P computed the two diametrically opposite elements. See that? So these are the two diametrically point P, two diametrically opposite element. The point P gives the two diametrically opposite elements. What are the two diametrically opposite elements? Means DL. What are the points the element present means? C, one point, another point is what is that? D. So consider two diametrically opposite element on the circular coil. What are the diametrically opposite? See that I will circle that. This DL is the two diametrically opposite elements. They are present in the circle, the two different points. One of the point is C, other point is what is that? D. So the diametrically opposite element is represented by the element of length. The element of the length. What is that element of length? DL. And where is the element present in the circular coil? Circular coil carries the current. No. So current element. Current element of the length is represented by I into DL. What is that? See that? I will box no. So DL represented by element of the length. Otherwise, consider small element. No, that element length. What is ideal? When the element present in the circle or circular coil, in the circular coil flowing the current, so we can multiply with the length of the element into current. That's the current element of the length. Our aim is to find out what is the magnetic field in the circular coil. Already I informed we can't directly find the magnetic field around the circular coil. That's why we have to assume the point P. First we have to find the magnetic field in the point P. Then we have to calculate magnetic field around the circular coil. How to find the magnetic field means in our previous class we have discussed one law, Biot and Savart law. Use the Biot and Savart law to find the magnetic induction or magnetic field at the point P. So according to Biot Savart law, what is that Biot and Savart law means? dB vector notation mu naught divided by 4 pi ideal vector into r cap divided by r square. We are derived in our previous class. Am I correct? So using this equation or this law, we can apply this equation here. dB Biot Savart to find the magnetic induction. How to find? Using Biot and Savart law. Biot and Savart law. First, we have to apply the magnetic induction at the point P to find the magnitude at the point P. Magnitude means what amount of magnetic field acting at the point P. But here two diametrically opposite elements are there. No. So the magnetic induction resolved in the point P into two components. What are the two components? Means one is horizontal component one is vertical component. What are that? Horizontal component. Another one is vertical component. Here, see that I'll show that axis. This is y axis. This is z axis. Then what is this? X axis. Here, horizontal component, which axis means y axis. Vertical component, which axis means this is z axis, y axis. Then z axis. So vertical component acts along the y axis, z axis. Horizontal component acts along the z axis. So how that resolved into vertical and horizontal component? I will draw, see the diagram. See, these are horizontal component. This is what is that? Vertical component. So horizontal component in the y axis. No. So magnetic field or magnetic induction in the horizontal component y axis equal to dB sin theta. This is center point and this is dB y opposite direction, dB sin theta. So vertical component, this is vertical component. What is the vertical? dB cos. So dB, which axis? Z axis. dB z axis, dB cos theta. Same for that here, dB Z equal to dB cos theta. Here see that vertical components acts in the same direction, but horizontal components acts in the opposite direction. So what happened? The magnetic induction in the horizontal component cancel to each other because they are in the opposite direction. That's why they are cancelled to each other. That's why they are cancelled to each other. What about the horizontal component? Means the horizontal components in the acts in the same direction. No. So they are to added in the point P. See, I will draw the diagram. This is point P. Theta. This is 90 degree. And this angle also theta. This is very important. Diagram is very important because we have to derive the equation part. So theta, here one circle. Here, when the how to find the magnetic induction at the point P means we have to use the horizontal and vertical component. Here horizontal component in the y axis that represented by dB sin theta. What is that vertical component? That represented by dB cos theta. Here dB sin theta, that angle is to be cancelled because they are in the opposite direction. But dB cos alpha or cos theta we can add because they are acting in the same direction. That means vertical direction. Both of them act in the same direction. Next, we have to find the dl. See the equation number 1. In the equation number 1, how to find that dl? We have to integrate to find the length of the element. What shall we do? Means integrating that. What we will do? Integrating the dl. What shall we do? Integrating the dl. If you integrate, we are getting the dl. Okay. So from the diagram, see that? From the diagram, I want to write certain angles. So what are the angle I want to write? Means see that angle COP equal to then DOP. Refer the diagram, angle equal to theta. Any doubt? Angle COP and DOP, what is that angle? That represented by theta. Any doubt if you ask suddenly? Next, here is 90 degree. So this diametrically opposite lengths are r vector. This is also r vector. Next, here see that using Pythagoras theorem to find r. In the lower classes itself you have studied derived Pythagoras theorem, no? So R equal to root of R square plus Z square. See how I write this equation. This is that diagram. This is R. This is Z. What is that? This is R. O D P. I want this value. R. So R equal to, using Pythagoras theorem, root of R square plus Z square. The magnetic induction acting at the point P that resolve into two components. How that means? The magnetic induction acting at the point P resolve equally because the two elements, diametrically opposite elements, are equal distance of the circle from the point P. That's why the magnitude of the magnetic induction on the point P are equal. So R equal to root of R square plus Z square. Next, how to find the DL? DL to find, we have to integrate that. So 0 to 2 pi R. What is here? O to 2 pi R. Circumference of the circle 2 pi R. So we have to use that. I will explain why we want to use. Next, from the diagram, using the triangle, what is the triangle means? DOP. I want to find the cos theta. So cos theta means in the trigonometric ratio, what is that? Adjacent by hypotenuse, isn't it? So what is here adjacent? R is the adjacent. What is hypotenuse? R. Isn't it? Here R already we are derived. So R divided by root of R square plus Z square. Consider this is equation number 2. What is that? Equation number 2. Already we are DL. How to means integrate that 0 to 2 pi R. Next, these values we have to substitute. Where we have to substitute means see here dP equal to. Otherwise, to find the total magnetic induction. What is that? To find the total magnetic induction. To find the total magnetic field or induction. How to find means see that the magnetic induction to find B equal to integration of dB cos theta. What is that? Cos theta into K vector. K vector is nothing but. So to find the magnetic field at the point P, total magnetic field, that means whole circular coil, how much magnetic field find means. So we have to integrate the, we are already derived equation number 1. So dB, why I added here cos theta means because when the magnetic induction acting at the point P, they resolve into two components. One component is cancelled into each other, but the other component is acting vertically in same direction. That's why I added. That is what is that cos theta. Now we knew that dB value, cos theta value. Substitute and getting the equation. See, B equal to integration of what is dB? See that equation number. What is the dB? Mu naught by 4 pi, isn't it? So next I dl by r square into r cap into what is that? Cos theta. If you write that r cap, no need to write k vector or k cap. Otherwise, if you don't want to k r cap, you want to write what you want to write? Cos theta into what is that? K cap. Both instead of r vector r cap, I want to use k cap. That both are unit. Just change that. Now substitute that. So what are the things are constant? Mu naught I divided by 4 pi is constant. Rest of them 0 to 2 pi r integration. That means limits. So dl into cos theta. We got it cos theta value. What is the cos theta value? R divided by root of r square plus z square into k cap. Into k cap. Any doubt about these equations? Don't confuse because full and full equation. You move step by step, then get that equation very clearly. Okay. Once again, I will remember. consider a current carrying circular loop of radius r. Consider what is I means that current in the circular loop flowing in the direction. I mentioned the arrow mark. So the element, we have to find the magnetic induction at the point P. So we have to find the magnetic induction at the point P. What is the reason we have to find the magnetic induction at the point P? Means because we can't directly find the magnetic field or magnetic induction through the circular coil. First we have to assume the point P, then we have to find the whole magnetic field in the circular coil. So we have to assume the two diametrically opposite element dl and dl. The distance between the two diametrically opposite element from circular to the point P is represented by r vector. Then P to O, center of the coil, is represented by Z. So current carrying current element of the length I into dl. According to using Biot-Savart law, we have to find the magnetic induction at the point P. So dB vector equal to mu 0 divided by 4 pi ideal vector into r vector, r cap by r cube. When the magnetic induction acting at the point P, but the point between two diametrically opposite acting at the point P, no equal distance, the magnetic induction also same because equal distance. They resolve into two components. One is horizontal component in the y-axis, vertical component another the z-axis. So I will show the diagram how that vertical component acting, how that horizontal component acting. Here horizontal component the sine angle, they are acting in the opposite direction, cancel each other, but vertical component cos angle, they are acting in the same direction. Then we can add that. So next to find the length of the element. The length of the element present in the circular. So we have to integrate it, we are getting the length of the element. So 0 to 2 pi r, integrating limits. From the diagram I have written the statements, angles, then r, small r, the length. Then we have to find the total magnetic field at the point P, then to find the total magnetic field on the circular coil. So V equal to integration of dB cos theta into k. Substitute the dB value and k. And what are the terms or constants taken out? Then the rest of that we have to integrate. Already if you integrate the integration of dx is nothing but x. So there dl is there. So integration of dl is nothing but, see that integration of dl. This term we have to integrate. When I circle no. So b equal to mu naught I divided by 4 pi. See that if integrate they are getting L because integration of dx equal to x formula. So integration of, if you remove that x, what is that? Integration of dl equal to what is that? L. So rest of the term r by root of r square plus z square. My convenience I write like that, r square plus z square to the power of 1 by 2 into k cap. So next mu naught I divided by 4 pi. What is limits? Means 2 pi r to 0. Upper limit is 2 pi r. 2 pi r minus 0 formula r divided by r square plus z square to the power of 1 by 2 k cap. Then one more factor is there, isn't it? See that here r square dl by r square. So here also L by r square. So by r square. How to find out r square? Means using Pythagoras theorem from the diagram, r square plus z square. R means see root of r square plus z square. R square means r square plus z square. This value, the r value, r square value substitute mu naught I divided by 4 pi 2 pi r divided by what is that? R square plus z square. Rest of the term r divided by r square plus z square to the power of 1 by 2 into k cap. So here maximum, what are the terms? We cancel 4 pi 2 pi, rest of them 2 is there. So mu naught I divided by 2 in this here. So r into r square by r square plus z square to the power of, if you using the mathematical step for this 2, what you will get means you will get r square plus z square square to the power of 3 by 2. Okay, so what is the total magnetic induction or magnetic field along the circular coil? Mu naught I divided by 2 R square divided by Z square, otherwise R square Z square to the power of 3 by 2 into K cap. If vector notation, all should be vector notation. So V vector. So this is our required final equation. V vector equal to mu naught I by 2 R square divided by R square plus Z square whole power 3 by 2. Don't confuse how that R square plus Z square, R square plus Z to the power of 1 by 2. This is very simple mathematical form. You will try in your home. You are getting the equation this step. So 1 into 1 power, that means 1 into 1 by 2. We are getting 3 by 2. Any doubt in this question, please ask me. So we have moved to the next topic. So we'll move next topic. We have derived the last equation. What is the last equation we derived? B vector equal to mu naught I by 2 R square divided by R square plus Z square to the power of 3 by 2 into K vector. See? So our next topic, current loop as the magnetic dipole. So the current loop as a magnetic dipole. So I hope we are already discussed magnetic dipole, isn't it? So current loop, the simple current carrying loop as a magnetic dipole. How that current loop as a, this is 3-mark question. So we have derived just now the final equation. What is the final equation? B vector equal to the magnetic field at the current carrying circular loop or circular coil, that is current loop. What is that? Mu naught I divided by 2 R square divided by R square plus Z square to the power of 3 by 2 into K. This equation just now we derived. Am I correct? So using this equation, now to find the current loop as a magnetic, what is that? Current loop as a magnetic dipole. Current loop as a, what is that? Magnetic dipole. So current loop as a magnetic dipole. How that means? From this equation, the above equation, I want to apply certain. What is that means? Here Z is very greater than R. If compare R, Z is, what is that? It is I. So R square we have to, that means Z square, that means R value we have to neglect in the denomination factor. So V vector equal to mu naught I divided by 2, numerator in the R square divided by that R square we have to remove. The rest of the term, what is that? Z square to the power of 3 by 2. What is the reason? I written the condition. See that? What is the condition? Z is very much greater than R. Is very much greater than R. So R square plus Z square. We have to write R square plus Z square is nothing but, what is that? Z square. This is the condition. From the diagram, where this condition I took in from the diagram. You remember that where I took this condition from the diagram. So see here, this 2 here cancel. Rest of the term B vector equal to mu naught I divided by 2 R square by Z, if the rest of them Z cube into K cap. From that, using area of the circle, area of the loop. So what is that? Here represent area of the loop. A is equal to pi R square. So then R square equal to what will come? A by pi. Here this R square value you want to substitute. Where you want to substitute means I showed the mark here. So rest of the term B vector equal to, so mu naught I divided by 2, isn't it? See that? Instead of r square, what I want to substitute? A by pi. What is that? A by pi. In the denominator, what is there? Z cube is there. Into k cap. Into k cap. What is that? Into k. I rearrange the equation. Mu naught divided by 2 pi I into a divided by z cube. I into a z cube vector into k cap. Consider this is equation number 1. The equation number 1, we have to multiply and divide into 2, both numerator and multiply and divide by 2. In equation number 1, multiply and divide by 2. By what is that? 2. What will get? See that? B equal to, that means B vector equal to mu naught divided by, if you multiply 2 pi into 2, 4 pi, isn't it? Am I correct? Then 2 into IA divided by Z cube into K cap. This is equation number 2. See that? If you see the equation number 2 and both equations are same. Equation number 1, I didn't multiply and divide both denominator by 2. But equation number 2, I multiply and divide in the equation number 1 by 2. That's why this equation is applied. From equation number 1, see that? From equation number 1, so here PM equal to IA. What is that? PM equal to IA. What is PM means? Here PM represent magnetic dipole moment. What is that? Magnetic dipole moment. What is IA represent? Magnetic dipole moment. In vector form, we can write PM. This is vector. So I into A vector. Very important equation. Equation number 3. This equation number 3 represents current loop as a magnetic dipole. So magnetic dipole is defined as the product of the current in the circular coil and the area of the circular coil. What is that? So magnetic dipole moment around the current carrying circular coil is defined as the product of the current in the circular coil and the area of the circular coil gives the magnetic dipole moment. Very simple. If you use this equation number 3, they will give the problems. 1 mark problem, 2 mark problem, then compulsory problem, competitive exam problems. Okay, they give the current and area. We can find the magnetic dipole moment. Okay, what we have to find? Magnetic dipole moment. If you have any doubt in this question, please contact me. So very simple one, current loop as a magnetic dipole. How to derive means we already derived to find the magnetic field or the current carrying circular loop is there. No, using that final equation, that question final equation, we have to derive current loop as a magnetic dipole. Okay, thank you. Good morning students, I hope you all are good. Today we are going to discuss lesson 3, magnetism and magnetic effect of electric current. In that lesson we have discussed number of topics, isn't it? Today we are going to discuss a new topic. What is that? Magnetic dipole moment of revolving electron. What is that? Magnetic dipole moment of revolving electron. This is very important 5 mark question and problem question also. So you will listen very carefully and take down the notes. What is our question? Magnetic dipole moment of revolving electron. In our lower classes we are studied, that means if you are studied, when the electron revolving around the nucleus, what happens? They give the current, electric current, isn't it? Am I correct? In our previous chapter, current electricity also, the state, when I gave the statement, no, we have discussed. Suppose an electron undergoes circular motion. What is that? An electron circular motion where around the nucleus. So first point, as suppose an electron undergoes circular motion around the nucleus. See the diagram. This is circle. An electron, here me mass of the electron around the circular motion in anti-clockwise direction. Which direction? Anti-clockwise direction. This is nucleus. So when the electron, see that this is electron revolving around the or undergoes circular motion. What happened? An electron in the circular motion, electron in the circular motion in a loop. What loop? Like circular loop. The loop is circular. An electron in the circular motion in a loop. That means the loop is what is that? Circular. What happened? That like a current in the circle. What happened? Current due to the circular motion, electron around the nucleus, they give the circle. Current in the circle. If you use this, we have to find the, what is that? Magnetic dipole moment. What we have to find out? Magnetic dipole moment we have to find. Due to this reason, the above reason, we have to find magnetic dipole moment. So magnetic dipole moment represents nu L. Actually, this is orbital magnetic dipole moment equal to I into E, equation number 1. What is E means? Charge of the electron. What is I? Current in the circular coil or circle. So due to the electron revolving around the circular or circle, they produce the current, they give the magnetic dipole moment that represented by mu L equal to I into E. What is that? I into E. Next, we have to find the time period. What is that? Time period. And also we know that what we know, so mu L in the vector form, we have write I into A. Just in our previous class, we have discussed magnetic dipole moment. Here mu L, I use that I into A. This is vector notation in magnitude. In magnitude, mu L equal to IA, equation number 2. Equation 1 represents in the vector notation, equation number 2 represents magnitude. So, next step, time period. What is here? T indicates T is the time period. How much time taken to complete the electron around the circle? So, how to find out means we can use the equation I equal to minus E by T. How this equation obtained means because when the electron revolving on the circle, they produce the current. So current is equal to minus E by T. What is here? E means charge of the electron. What here? E charge. Charge of the electrons. What is T? Time period. Here negative sign. The charge of the electron is negative. That's why it is, what is that? Negative. I is equal to. Next, time period we have to calculate. T is equal to circle 2 pi r divided by v. V means velocity. R radius of the circle. See, v velocity of the electron revolving around the circle. So we have to calculate the time period T. Equation number 3 and equation number 4. Substitute equation number 4 in. Substitute equation number 4 in equation 3. We are getting current, isn't it? So I is equal to minus E in the numerator. Denominator what will come? 2 pi r divided by v. This v move into the numerator. The current gets minus EV by 2 pi r. This is equation number 5. Any doubt about equation number, how that the equation number 5 obtained? It is very simple question but full and full mathematical. You will carefully follow the mathematical step and also theoretical. Theoretical is nothing. An electron undergoes circular motion around the nucleus. When the electron around the circular motion in the circular loop, what happens means they produce electric current. Due to the electric current, they give the magnetic dipole moment. Already we have discussed magnetic dipole moment equation in mathematical vector notation in the ordinary form. I in the A represents area of the circle. So T is first we have to find out current. I is equal to minus E by T. Then time period 2 pi R by V. So substitute the equation 4 in equation 3. We are getting current. This now equation substitute. Equation 5 in equation 2, we are getting magnetic moment. Mu L equal to, what is that? I, we got it I, minus EV by, what is that? 2 pi R, isn't it? Rest of the term A. Here, what is A indicate means A is nothing but area of the circle pi R square, isn't it? A is nothing but what is that? Pi R square. Now substitute this value here when I arrow mark that. So mu L equal to minus EV divided by 2 pi R, rest of them pi R square, isn't it? So here pi cancel, R minus EV R divided by 2 mu L. Equation number 6. How that equation number 6 got it? If you have any doubt, please ask. Mu L equal to minus EV R divided by 2. Here, what is A? Denotes that A is nothing but pi R square. Area of the circle, R, radius of the circle. About the so next we have to use that angular momentum. What is that? Angular, because the electron revolving around the circle. No, so no linear momentum. Here we have to use angular momentum. Angular momentum represented by L, isn't it? L R into P, L vector. If you denoted in the vector notation, in ordinary notation, L is equal to R into P. Now substitute L is equal to R directional change. P is equal to what is that? mv. Linear momentum, mass into velocity. So mvr. Equation number 7. See that? Now divide equation 6 by 7. Isn't it? Now divide, what is that? Equation 6 by. Now divide equation 6 by 7. That means 6 divided by 7. So what we will get? Mu L, let's say first by L equal to numerator minus EVR divided by 2, isn't it? In the denominator, MVR. So what are the terms cancel? R cancel, V cancel. Rest of the term, E by 2M. What is that? Mu L by L. This term, what is that? Minus E by 2M is represent gyro. Very important one more question. Gyro magnetic ratio. What is that? Gyromagnetic or gyromagnetic ratio. To find the gyromagnetic ratio, not this one. To find the gyromagnetic ratio, consider this is equation number 8. From equation 8, to find the value of equation 8, so mu L divided by L is represented by gyromagnetic ratio. So what is that? Minus E by 2M. We know that the value charge of the electron. What is the charge of the electron? 1.60 into 10 to the power of minus 19 divided by 2 into mass of the electron. These are fixed value. 9.1 into 10 to the power of minus 31. When you solve this, you are getting mu L by L equal to minus E by 2M. What you are getting means 0.878 into 10 to the power of 12. So mu L by L equal to 8.78 into 10 to the power of 0.0. If you will use that, you will calculate that. These are fixed values, so no need to just you have to 8.10 to the power of 10 coulomb per kg. Unit of gyromagnetic ratio. What is that? Coulomb per kg. What is this? Gyromagnetic ratio value. Repeated one more question. The last, what is the unit of gyromagnetic ratio? Coulomb per kg value 8.78 into 10 to the power of 10. Otherwise 0.0878 into 10 to the power of 12. Okay. Any doubt in the gyromagnetic ratio also represent minus E by 2m here. What is here indicating? Minus means the charge of the electron is negative. So next we have to use that Niels Bohr quantization. We will discuss what is Bohr quantization in our 8th lesson. So Bohr quantization condition. What is that Niels Bohr quantization condition? Means angular momentum L is equal to n into h cross. Here h cross is nothing but h by 2 pi. What is that? H by 2 pi. Substitute L is equal to n h by 2 pi. Consider what is our last equation? Last equation 8. No, this is equation number 9. Equation number 9. How that equation number 9 I written means using Bohr quantization condition. How directly Bohr quantization condition I used? Because we are going to discuss in our 8th lesson Bohr quantization condition. That one statement I took that angular momentum L is equal to n h cross divided by h cross. H cross value h by 2 pi. So L is equal to n h divided by 2 pi. Substitute these values. That n value where we want to substitute means, see that I will remodify the equation. Which equation I will remodify? New equation number 8, mu L divided by L equal to E by 2m. I remove that negative. So this equation I have to change mu L equal to E by 2m into L. If L value we know that, this is equation number 10. This equation I took from equation 8. Substitute equation number 9 in equation number 10. So mu L equal to E by 2m. There is no change. What is L? We got it. NH divided by 2 pi. Isn't it? So I rearrange it. E n h divided by 2 into 2, 4, so 4 pi m. So mu L. Here what is h means? Planck's constant. This Planck's constant value 6.626 into 10 to the power of minus 34 joule per second. What is that? Joule second. So what is h denotes? H denotes Planck's constant when number of values here no. N value is nothing but that is the principal quantum number. It starts 1, 2, 3, 4, etc. N is n value. So rest of the value, charge of the electron we know, mass of the electron we know. We have to substitute in the equation number 5. We are getting the value mu L. So mu L equal to. So E value we know that. What is that E value? N is constant. N value 1, 2, 3. We knew that. We have to apply. So 1.6 into 10 to the power of minus 19 into h divided by 4 pi m. 4 pi into 9.1 into 10 to the power of minus 31. What is that? Mass of the electron. Next we have to substitute h value. Then 4 pi value we are getting the mu L value. So mu L equal to, see here, n there is no change. N into 1.6 into 10 to the power of minus 19 into 6.626 h value 10 to the power of minus 34 divided by 4 into 3.14 into mass of the electron 9.1 into 10 to the power of minus 31. When you solve that, you are getting mu L equal to n into 9.27 into 10 to the power of minus 24 ampere per meter square. The unit of orbital magnetic moment. So here mu L becomes minimum. What is that? Mu L is nothing but minimum that represented by magnetic moment. What is that? Mu b, magnetic moment. Magnetic moment. So that magnetic moment represented by mu b equal to NEH divided by 4 by m. When this is actually Bohr magnetron. What is that? Bohr, important one more question. Bohr magnetron. NEH divided by when n is equal to 1. What is that Bohr magnetron? Mu b equal to EH divided by 4 by m. Because the orbital magnetic moment going to minimum. See that I written here. Mu is equal to minimum. So that represent converted into magnetic moment. Bohr magnetic moment or Bohr magnetron or magnetic moment. So Bohr magnetron value. What is that Bohr magnetron value means? When you substitute, when n is equal to 1, what we are getting the above equation? 9.27 into 10 to the power of minus 74 am. This is very important one mark question, and also many times they ask this last equation, Bohr magnetron. Our last equation 11, so you consider equation number 12, note it down. Equation number 12, they will give the value of n is equal to 2, n is equal to 3 to find the Bohr magnetron when the orbital quantum number or quantum number, when the electron revolving around the third circle, when the electron revolving on the fourth circle, then mass of the electron, suppose if instead of the electron we are moving to proton, what is the value of the Bohr magnetron? We have to find that. Now see, when the electron revolving around the anti-clockwise direction, the current is the clockwise. When the electron in the clockwise direction, then the current in the anti-clockwise direction. This is the final statement. So magnetic dipole moment of revolving electron. When the electron revolving around the circle, they give the current, and also what is that? Magnetic dipole moment, zero-magnetic ratio and Bohr magnetron. Zero-magnetic ratio, what is the value of zero-magnetic ratio? 8.78 10 to the power 2 unit coulomb per kg. Always you should remember this equation because they use this equation, they ask problems. If you have any doubt in this question, please ask. Step by step you solve. It looks like mathematics, so you don't confuse it is mathematics or physics. It is definitely physics. Okay, thank you.